Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to Doctor and also to all my friends. So today I would like to present the experiment 2, and the task that I've been given is task D and E. Task D is carboxylic acids, amines and esters, and for task E is amines. So before getting any further, let me introduce myself first. My name is Nurfarana Suha binti Muhammad Hassan Amri. My metric number is 17205953 from Occurrence 1, and my lecturer is Dr. Abdullah Al-Hadi bin Ahmad. So first of all, we're going to start with the title of the experiment. The title is Chemical Properties of Hydrocarbons, Alcohols, Aldehydes, Ketones, Carboxylic acids and amines. So the objectives of this experiment is to identify the functional groups in compounds. Next is to be able to describe the structure and properties of functional groups such as aldehydes, ketones, carboxylic acids, esters, and others. Lastly is to explain why the properties of a given organic compound are largely dependent on the functional group or groups present in the compound. So there are a few experiments that I've recognized based on the given videos. The first one is from section D. It is the reaction of carboxylic acid with sodium bicarbonate solution. The second one is section D, the test for the ester. And the third one is section E, the Hinsberg test for amines. So we're gonna see the first one, the first experiment, which is reaction of carboxylic acid with sodium bicarbonate solution. The carboxylic acids that involved in this experiment is ethanoic acid and also benzoic acid. Next, we go on to the procedure. First, 1 milliliter of 5% sodium bicarbonate solution was placed in a watch glass. Second, 1 to 2 drops of carboxylic acid or 0.1 gram if solid was added. And the third one, observation was recorded. So down there I've put the reaction, which is carboxylic acids that react with sodium bicarbonate solution will produce the carboxylate anion and carbon dioxide gas and also water. Okay, so Bismillahirrahmanirrahim, we're going to start with the reaction between carboxylic acids and the sodium bicarbonate solution. So the first acid is the acetic acid and the second one is benzoic acid. So before that, let us recap that every acid will donate H+, and every base will gonna accept H+. Okay, so the first acid is acetic acid. So as we know, acid, it will donate H+. So the H+ or the ion hydrogen that gonna be donated is from the functional group of the carboxylic acid itself. So we're going to donate this H+. So after the H+ is being donated, then it will leave the negative charge behind. Okay, and then the H+ that had been donated will then combine with OH negative from the base and produce water. H2O. This is water. And then we can't have this anion hanging around itself, this anion. So we need to pair it up with a cation. So where do we find the cation? We find it, the cation is from the base, the Na. So we add the Na plus at this carboxylate salt. Okay, so and then we know that this reaction is not complete yet because we still have remain CO2 from this base. So we're just going to add CO2 over here, and then that's it. So this is the salt that we just made, and we're going to call it a carboxylate salt because this is the salt that produced by the reaction from the carboxylic acid and the base. So the next acid is benzoic acid. So the benzoic acid has a structure like this. It's the same goes to like the acetic acid. It is benzoic acid react with base, then the H plus from the acid will be donated to the OH from the base, OH negative from the base. So it's gonna produce H2O also, and then gonna leave this negative over here. So we can't have this anion hanging around itself, so we need a cation from this base to fill in this anion. And then what left is the carbon dioxide from the base. Oops. Okay, so now we have produced the carboxylate salt, and this is what it called as carboxylate salt. Okay, that's all. And now it's time for the results. For compound ethanoic acid, I put clip 76 as its observation because in that clip, what I'm observed from that clip is there is a lot of small bubbles immediately appears. The next one is compound benzoic acid. I put the clip 77, and what I observed from that clip is the solid is moving a little bit and only some tiny bubbles appears. So next we are going to the best part, which is discussion. So as you can see, I put a little note up besides the discussion, which says strongly acidic compounds such as carboxylic acid will react with sodium bicarbonate solution to form the water-soluble salts, and the reaction also produces bubbles of carbon dioxide. So the bubbles that appears from our observation is actually carbon dioxide, and it appears because the reaction of sodium bicarbonate solution with these carboxylic acids. Okay, so for ethanoic acid, it dissolves in sodium bicarbonate solution, and it dissolves in that solution faster than the benzoic acid because, as we can see, the small bubbles appear quicker and faster, and also a lot more bubbles appears in the ethanoic acid when it reacts with sodium bicarbonate solution. So what we can conclude that it has a smaller number of carbon, as we can see in this molecular formula, and shorter chain length, thus make it react faster in the basidic solution. For the benzoic acid, it dissolves in sodium bicarbonate solution, but however it dissolves slowly in that solution and slower than the ethanoic acid. So this is because it has a benzene ring at longer chain length, therefore make it react slower in the basidic solution. So now we are moving on to the next experiment. This experiment is the test for ester, and the esters that involved in this experiment is ethyl acetate and methyl benzoate. So the procedure for this experiment is first 1 to 2 drops ethyl acetate was added to a saturated alcoholic solution of hydroxylamine hydrochloride, 3 drops, and a methanolic solution of 20% potassium hydroxide, 3 drops, in a test tube. And then the mixture was heated to boiling, and the mixture was cooled and acidified with 0.5 molar hydrochloric acid hydrochloric solution, and then iron trichloride solution was added drop by drop to the mixture. And then after that, the observation was recorded and the test was repeated with methyl benzoate. So down there I put a reaction scheme, which is the ester will react with hydroxylamine in the presence of the sodium hydroxides to form the sodium salt of corresponding hydroxamic acid. So on acidification and addition of the iron trichloride as it's shown in the procedure, and then the magenta colored iron 3 complex of the hydroxamic acid is formed. And when the magenta colored solution is formed, that means it is ester. So now moving on to the results. For compound ethyl acetate, I put clip 78 as my observation because in that clip, what I can observe is a brown reddish solution or the magenta colored solution. And then for compound methyl benzoate, I choose the clip 79 because in that clip I can observe a brown purplish solution which is burgundy colored solution. Next we're going to discuss about the test. So the first compound is ethyl acetate. So we can say that it is an ester because it produces magenta solution, which indicates the magenta colored iron 3 complex of the hydroxamic acid. So that's why we can know that it is ester. And then the next one is methyl benzoate. It is also an ester because it also produces magenta sort of an burgundy solution, which indicates the burgundy colored iron complex of hydroxamic acid. Now the third test is from section E, which is amines, and the test called Hinsberg test. And the amines that involved in this test is propylamine, diethylamine, triethylamine, aniline, N-methylanilene, and N-dimethylanilene. The procedure for this test is 5 ml of 10% sodium hydroxide solution and 0.4 ml benzene sulfonyl chloride were added to 0.3 ml of propylamine or 200 mg if solid in a test tube. Then the test tube was toppered and the mixture was shook vigorously. The solution was tested to make sure that it is still alkaline. After all of the benzene sulfonyl chloride has reacted, the solution was cooled and the residue was precipitated from the solution, if any. And then the solution was treated with 10% acid hydrochloric solution and observations was recorded. So if it is primary amines, it will dissolve in base and precipitate in acid. And then if it is secondary amines, then it have the precipitate in base but no change in acid. And then for the tertiary amines, it will precipitate in base and dissolve in acid. And the test was repeated by using propylamine, diethylamine, triethylamine, aniline, N-methylanilene, and N-dimethylanilene.
Okay, Bismillahirrahmanirrahim. Now we are going to see the reaction for the Hinsberg test, and then the reagent that we will be used is the benzene sulfonyl chloride. So the first one, we're going to test the primary amine over here. So as you can see, the primary amine, there is only one alkyl group that attached to it, and there are another two hydrogen atoms that attach to nitrogen, and then it will react with the benzene sulfonyl chloride in the excess of sodium hydroxide. Okay, so let's see. In the primary amine, we can see there are two hydrogen atoms, right? So the first one, it will react with the chloride ion in this from this benzene sulfonyl chloride to form the hydrochloric acid over here. So another hydrogen over here, which is acidic because it is attached to the nitrogen, it will react with the excess of sodium hydroxide over here. So when it reacts with the sodium hydroxide, it will form the ionic bond, as you can see here. So The product is a water-soluble salt, and we can observe it as clear solution. And then after that, the mixture will then acidify with hydrochloric acid, and as you can see, the product does not contain any ionic bond, so we can observe it as white precipitate. So next we are going to see the tertiary amine. As we can see over here, there is no hydrogen atom attached to it, and there are all alkyl groups that attach to this nitrogen atom. So because there is no hydrogen atom attached to the nitrogen atom, thus the tertiary amine does not react with the benzene sulfonic chloride. So we can see that there is no product for the reaction with the excess sodium hydroxide, and we can observe it as a clear solution. But then the reaction of hydrochloric acid, the tertiary amine will form an ionic compound like over here, so that we can observe it as a clear solution as well. Okay, so now we are moving on to the secondary amine, as we can see over here. So as we know, secondary amine has only one hydrogen atom attached to the nitrogen. So this hydrogen atom then will react with this chlorine, and it will produce this hydrochloric acid. And then we then observe the product as white precipitate. Okay, so for the reaction with hydrochloric acid, there is no observable changes, means there is no reaction for it. Why white precipitate does not dissolve in sodium hydroxide? It is because there is no acidic hydrogen like in the primary amine. So that's why it doesn't dissolve in the sodium hydroxide or in a basidic solution. This is the Hinsberg test reaction.
So now moving on to the results section, I will tell you the compound and also the observation in acidic solution. For the first compound is propylamine. What I've observed in the clip number 81, there is small white precipitate formed. The next compound is diethylamine. What I've observed from the clip number 85, there is colorless solution. The third compound is triethylamine. I choose clip number 80. A white suspension is formed. And then the next compound is aniline. What I'm observed from clip number 83 is murky solution. The next compound is N-methyl-aniline. I choose the clip number 82 as it has the brown solution. It produces brown solution. And the last compound is N-dimethylamine. I choose the clip number 84 as it's slightly brownish. It's produced slightly brownish solution. There is no observation in base because we didn't get the video for the reaction with amines with the base. So next we are going on to the discussion. For the first compound, which is propylaniline, the propylaniline is primary amine because there is small precipitate formed. So it means that this amine is react to the acidic solution and it formed the sulfonamide salt of sodium. Means the small precipitate that formed is the sulfonamide salt of sodium. The next compound is diethylamine. So diethylamine is secondary amine because it didn't react to the acidic solution. Because what I've observed from the clip, there is a colorless solution produced. Means there is no reaction. Next, the third compound is triethylamine. The triethylamine is tertiary amine because it dissolves in acidic solution. So, and the white suspension that is formed is probably due to the reaction with the acidic solution before, with the sodium hydroxide before, and it not filtrate. It doesn't filtrate fully filtrate. So probably the white suspension was because of the reaction of the triethylamine with the basidic solution before. It is because the triethylamine it didn't dissolve in the basidic solution. So moving on to the next compound is aniline. Aniline is primary amine because the murky solution that formed in the test tube means that it didn't dissolve in acidic solution, which is hydrochloric acid. And then the second one is the fifth compound is N-methyl-aniline. It is a secondary amine because the brown colored solution is probably due to the reaction in base solution. Then there is no reaction in acidic solution, means there is no reaction in hydrochloric acid. Okay, the next one and the last compound is N-dimethyl-aniline. It is the tertiary amine because of the absence of any precipitate and only produce brownish solution. This means that there is no precipitate formed, means that the N-dimethyl-aniline is dissolved in acidic solution, in hydrochloric acid. After all of the experiments by the given task had been accomplished, now we are moving to the precaution steps. So the safety precautions are: do not use thumb as a stopper. Use a stopper instead of using a thumb. And then swirl gently or put a piece of parafilm over the opening to mix solutions. Because we don't know, either the solution might be harmful or corrosive to our hands. Next, do not pour reagents and chemicals down the sink. However, dispose these only in designated waste bottle or container. This is because the spread of the chemicals down the sink will be able to cause harm to other lives. Then, when using hot plates, make sure to unplug them before leave. And lastly, if the glassware broken accidentally, clean up with broom and dustpan, and remember to dispose the broken glass in the designated containers so that other people won't be get harmed by it. The next slide is conclusion slide. So after all the experiments that had been carried out, we are able to identify the functional groups in compounds. Next, we are able to describe the structure and properties of functional groups such as aldehydes, ketones, carboxylic acids, esters, and others. And we also be able to explain why the properties of a given organic compound are largely dependent on the functional group or groups present in the compound. And conclusionally, all of the objectives have been achieved. Last but not least, these are the references that I've used to make this slideshow. Okay, then that is all from me, and thank you so much for listening. Assalamualaikum.